So I'm writing a remark now, and that remark is actually a quite long remark. Remark is something like this. If you take two numbers, suppose x is equal to 3.14 is the exact value of pi. Though this is just an assumption, so that's why I have written this word suppose, right? Nobody can write the exact value of pi, but I'm assuming that there are only 4 digits in the value of pi, right? Then the approximate value correct to 2 decimal places will be, if you write this value correct to 2 decimal places, you will be writing 3.14, and of course this value has 2 decimal digit numbers. After, you can see that there are 2 digits after decimal, that is 1 and 4, and both of them are correct. So do you agree with this? Both decimals are correct in this value x dash. Okay, then if you calculate the absolute error, and of course that is mod of x minus x dash, and if you subtract these two values, these two numbers, then you will be getting 0.00 and 28. Am I correct? Is it acceptable? Yes or no?
Yes, sir.
And this, yeah, this can be written as 0.28 multiplied by 10 to the power minus 2. Fine. So you observe that you were required to write the approximate value of pi correct to 2 decimal places, and that's why this 2 appeared in the power of 10 as negative, with negative sign. So had you wanted the approximated value of pi correct to 5 decimal places, then this power should be 10 to the power minus 5, right? There is a direct correlation between the number of decimal places you want, the correctness of any approximated value, and this exponent, means they both are same always. Right? So in general, if a number is correct up to n decimal digits, then EA is equal to some number multiplied with 10 to the power minus n. It means there will be some number. Fine, that's fine. So you accept this thing that if you write a decimal number like we wrote x is equal to 3.1428 correct to 2 decimal places, then we got 10 to the power minus 2 in the absolute error. And if I want to write a number correct to n decimal places, then I will be having 10 to the power minus n here. Is it right or wrong? 0.d1, d2, and dash dash dash. D1, D2, D3 are just digits, 2 digits. All of them are, D1 is non-zero, where the first digit should be not equal to 0. I hope you got this point. You can always see that as I told that in this number, the first number should be not equal to 0, right? Is it fine? The first number, because this decimal is required, just required before a non-zero number, right? And that's what I have written here, that this D1 is the first number which is appearing after the decimal point, and that should be a non-zero number. So I hope you got this, because this is very important. Clearly, 0.D1 G2 dash dash is a number between 0 and 1. That is 0, 0.d1, d2 dash dash less than 1. The maximum value of EA, if you see the value of EA here at this step, see this step, value of EA was 0.d1 d2 dash 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 multiplied with 10 to the power minus 2. So you're placing that by 1 because this time I am writing the maximum value of absolute error. Maximum means the maximum value of this special number. What is the value of this special number? Maximum value can be 1. So this is just the maximum value of absolute error. I hope you got this point. E A max is equal to 1 into 10 to the power minus n, or you may like to write it as the absolute error. If you remove the word max, the absolute error will always be less than or it may be equal to sometimes 10 to the power minus n. So this is another way to write maximum. You can see that there is this, or you can write it as 0. Sorry. 0.d1 d2 dash dash belongs to the interval 0, 1. You can write it this way also, right? So you can see that whenever something belongs to an interval, it is always good to write the average value, right? If you are saying that this number is the special number belongs to the window, this is a window, this is just a window, right? A small window of the interval 0 to 1, then you can always take the average. On average, you can say that this number is actually equal to half. So this is something like the clock tower. So for this interval, the clock tower is 1/2. The center point of this interval is 1/2. So that can be taken as the average value of error, because this is just giving you the maximum error. But in certain cases, in many cases, you just want the actual error, not the maximum or minimum error, right? So taking average of the length of interval 0, 1, we have EA equal to, and you can see that this is your special number, and you are replacing this special number by its average value, right? 1/2 into 10 to the power minus n. Okay. So these two formulas, you should remember these two formulas actually. In numericals, this is the absolute error, and this is the maximum. You can say that is the upper bound actually. Means error can be maximum 10 to the power minus n. It has to be less than this, and on average you take it half times 10 to the power minus n. If the number 8.6 has both the digits correct, then find EA means absolute error, ER means relative error, and EP, right? So these are just the formulas. We can use the formula of EA, ER, and EP, but the important point is here in this initial part of the question, where you are required to identify that what is the absolute error actually. The question will be not like the earlier questions where you are given a number and then you round off that number, then you have two values. The first value, the actual number, is called x, the rounded off number is called x dash. This question is very different. You need not to round off this number. 8.6 is absolutely what it looks like. 8.6 is the actual number, but it is certainly having some error. It means that every decimal number has some inherent error inside it. That's called defected by birth, right? 8.6 is a decimal number, but of course, it's both of its digits are correct. The question is saying that the number 8.6 has both the digits correct. So if both the digits correct, then there is error. In fact, every decimal number, uh, though it is correct, always has some error. And that error formula is given by the box formula. You can see the boxes of one orange boxes, 1 by 2 times 10 to the power minus n. So there's a problem with a decimal number. A decimal number always has some error, the error by birth, defect by birth, right? Since 8.6 has one decimal digit which is correct, thus n equal to 1. This n is actually the number of decimals. This is due to this 0.6, and then you calculate the absolute. Absolute is calculated, then we calculate the relative error, and that is EA upon the original number. What is the original number? 8.6. Right. And when you calculate EP is actually nothing but ER multiplied with 100%. So you just multiply this number by 100, so you're getting 0.58%. Fine. So next question is find ER and EP, right, in the number, and the number is 12.56 if it is correct to 4 significant digits, right? It means that there are 4 significant digits in this number, and if it is saying that 4 significant digits, then of course both the digits after the decimals are significant, and it is very clear that none of its digits are 0. So all of the digits are significant, because there's always a confusion when there comes 0, but luckily in this number there is no zeros, so all of the digits are significant. And since we have 2 digits after decimal, we have to focus on these 2 digits only. So n will be equal to -2, right? Since n equal to 2, not -2, n equal to 2, because in 12.56 due to 2 digits, right? Therefore, if we calculate EA, that will be how much? 0.005, and then relative error is obtained by dividing absolute error by the actual number, and the actual number was 12.56. So, and percentage error is equal to ER multiplied with 100%. The question is asking you to calculate the relative error, but in 2 different scenarios. The first scenario, and in this case, the actual number is X. 82.575, and for the first part, anybody know the meaning of truncation? Chopped off. If you chop off a vegetable, I hope you have heard about chopping off a vegetable. Then if you see that they require you in part A, it is truncated to 4 significant digits. You just take a knife, like you use knife while chopping a vegetable. Just take a knife and use a knife to chop the last few digits, so that you just have 4 significant digits left in the new number. So where should you place your knife? Absolute error is actually the difference of the actual value and the approximated value. So if you subtract these 2 numbers, we'll be getting 0.005, and relative error is equal to EA upon X. So this is the formula, 0.005 divided by the actual number. The actual number is 82.575, and in the second case, you have to round off the number to 4 significant digits. Then EA equal to mod of x minus, and that will be equal to 82.58 minus. Please subtract this for me. Please subtract 82.58 minus 82.575. I cannot use the calculator at the same time because my both hands are busy. Please use. And then I will calculate EA upon x 10 to the minus 5. Okay, thank you. So what do you think, which is a good answer? Which is good? Rounding off is good or truncating it is good? Rounding off is better because it is giving the less relative error, right? So absolute error is coming out to be same in both cases, and as I already said that absolute error is very misleading in certain cases. So relative error, if you compare the relative error in second case is good, case B. So that's why you can say that rounding off is preferred over what? Truncating, right? Truncating or chopping, both words are used. Truncating. Remark is that rounding off is better than what? Chopping or truncating.